So next we have challenges with the supply chain, and I texted. Okay, and we have Steve Jordan Tomaszewski leading the way, and Peter Wegner from BlackVe will be joining, as well as Chris Quilty virtually. We had to do some shifting. Well, Chris Quilty actually was supposed to be here earlier in the week and ended up having flight issues. So, and then you have another person?
Yes, David Beck.
Oh, David Beck. Okay, good. David Beck, calling David Beck. Oh, is that? Oh, good. And then there's a QR code if you want. Basically, what we're gonna do is the discussion that you add through the QR code. We'll have that ready to document in the report, but we'd really like for you all to plan on coming up and on the discussion time, come up, and then we'll also look and see what comes in through the QR codes too. So either way, but thank you, David Beck, for joining us, and Steve, take it away.
Do we have Chris Quilty? Chris, are you with us? Can you hear us?
Yeah, I can hear you good.
Perfect. All right. Thanks very much. All right. Well, welcome everybody to this co-innovation session on supply chain. So when I think of the state of the space industrial base, my first thought is the state of the supply chain. And I know that means a lot of things to a lot of different people, but was really kind of hoping to get to unpack that a bit here today, talk about the health of the supply chain, and really kind of have more of a hardware focus. And you know, there's a lot of changes happening in the space enterprise these days. We have satellite constellations that are getting proliferated. You know, what used to just be a handful of satellites is turning into thousands. We have lots of different developments happening with space launch vehicles. In the launch market right now, there's a lot of innovation happening there. But with all that happening, there's new materials getting used, new technologies getting integrated, new components, and it can stress the supply chain. So the other kind of context I think it'd be good to frame this in is we're realizing that sometimes there's actually a lot of vulnerabilities and challenges in the supply chain. There might be a lot of fragility, and I think there's challenges, recent challenges. I think even things like COVID really highlighted a lot of the supply chain issues that a lot of manufacturers had, whether it's even getting their hands on raw materials to start to make very low level components, or kind of some of those more advanced components and integrating everything together. I think COVID really kind of showed us where some of our vulnerabilities are, and especially where some of those manufacturing vulnerabilities might be. It could be just relying on a single mom and pop shop that might be the only company out there making a particular component, and I think there's been some vulnerabilities there. Also, recently, we've seen things like conflict have big impacts on the supply chain. The most recent invasion of Ukraine by Russia, I think, showed how we are a very interconnected global supply chain, and there were even a number of raw materials that we depended on in the space industry from Russia and Ukraine that the most recent conflict kind of highlighted and kind of dried up some of those things. I also think that a big challenge is inflation, right? And how that impacts everything. We've heard a lot from, especially the Department of Defense these days, about kind of shifting to more of a firm fixed price, contract model, which takes a lot of the risk away from the government. But if you pair that with things like inflation, and maybe you don't have a way to adjust those contracts later, there's certain a lot of examples these days where individual components might be 30-40% higher cost than they were the year before for a number of reasons. So inflation impacts are still with us. They're going to continue, and especially when we have a from the U.S. government perspective, fiscal constraints with Congress, kind of pairing that with how we're trying to put more capabilities in the hands of the warfighter at the end of the day, really, kind of highlight some of those challenges. Workforce is something that we constantly hear from companies of, being a big supply chain inhibitor. Of you have the generation of baby boomers starting to age out and retire, but you don't have the same level of experience and expertise kind of coming into the market and coming into the space industry to be able to really either manufacture parts, put things together, and I think it's just going to be an issue that's going to be growing for quite some time, and not just for STEM degrees and engineering jobs, but there's also a shortage of workforce when you're talking that skilled technical labor. Folks that are doing welding, machining, coding. Maybe they don't need to have a degree to do that, but I think that's something that's also a big challenge for the space industry right now. And so if we are identifying challenges in the supply chain, the question becomes, can we move quickly enough to actually fix anything? And what's the role of the U.S. government, if there is a role, to fix things? Because a lot of times businesses are just moving so quickly and responding to their customers, they might not have time to wait for a multi-year, government program to get up and running to try to fix an issue or vulnerability. So I think we're going to unpack a little bit of that here today. But then in the good news front, I think we do have a lot of opportunities right now looking at the space supply chain. So just have seen a lot of awareness happening out there. There's a lot of, especially folks from the U.S. government, they are listening to what is really troubling companies, which I think is something to really commend. Trying to understand where those vulnerabilities are, where the risks are in the supply chain, and trying to see, again, if there is a role for government to fix those types of things. You have major legislation that's getting passed, things like the CHIPS and Science Act, where the government recognizes that there might be supply chain vulnerabilities where it's appropriate to make a strategic investment to boost, especially domestic manufacturing capabilities, which, things like that, I think, are a great example of recognizing the problem and then trying to find solutions that are really going to help, especially our U.S. domestic industry across the board. Earlier this year, we saw the Department of Defense release the National Defense Industrial Strategy, which really tried to highlight the Department of Defense's role of recognizing those vulnerabilities and areas where that the Department of Defense would like to make sure that we're shoring up and adding some resiliency into the different supply chain. And then many of you may be aware there's been strategic investments from the Department of Defense that have also come into play. So things like Defense Production Act Title III funding that is actually making its way to try to fix issues in the supply chain, I think is something to recognize and give the Department of Defense some credit for. Last month, you might have seen that there was the first space-specific Defense Production Act Title III funding contract that was cut to shore up to help space qualified solar cells in the supply chain for that, and that was specifically for germanium, which is a kind of a critical mineral used in space qualified solar cells. But with all of the supply chain risks to the U.S. government overall, the space specific things is really what I was hoping we would unpack a little bit here today, and just try to understand, in the overall aerospace and defense industry, space might be a pretty small sector comparatively, but there's also a lot of very unique things to manufacture satellites and launch vehicles. It's really good to see that there are some solutions that are coming that especially the U.S. government is leaning forward on and trying to fix issues as they see them. So with that, I'm gonna do this. I'm gonna open it up to our panelists to maybe give some initial comments and thoughts about this topic. We're gonna dive into a couple of questions, and then we will also open it up to the audience here. So if Peter, maybe we'll start with you. Where are we with space supply chain, and how does your company see it?
Sure, happy to jump in. You guys can hear me okay. Well, first of all, thanks. I could talk about this topic all day long, and you'll probably have to yank the mic out of my hands at some point here because I get really fired up about this. And maybe to just go backwards through some of your comments a little bit. First, the issue of germanium wafers in solar cell production. If you're not all aware of this, today, currently, all of the germanium wafers that we build triple junction, multi-junction solar cells on that supply all of our high performance satellites on orbit, including DoD and commercial, all come from China. And that is the only source today for germanium wafers to build triple junction solar cells on. We identified that issue in the very first State of the Space Industrial Base workshop. I think Bucky will tell me the year. I think it was 2018. So it took us, how many years is that? 6 years to get to maybe a response, and it was great to see some money starting to move into that area. But what that means is at any point, the Chinese suppliers could decide not to ship germanium wafers to us, and we would very soon after that not launch another satellite. And so those kind of issues are really critical, and you have to dig really deep into these supply chains to understand where those kind of vulnerabilities are. So that's kind of comment number one. Comment number two about the workforce. I think this is a huge issue that is not well recognized across the country today. And that is, in fact, our population is declining. And if you look at the reports that are coming out on this, the current reproductive rate in the United States is about 1.7 children per adult woman. And the sustainment rate has to be above about 2.2. So the only way we are actually maintaining a consistent population today is through immigration. If you look at the rest of the world, they're in much worse shape than we are. Western Europe, Germany, France, they have much faster declining population rates. South Korea is the fastest aging population on the planet. And when you start looking around the world about where do we get these high-tech capabilities that we all enjoy and give us the quality of life that we have, they all come from countries that are over the next 10 years going to have massively aging populations and aging workforces. So this is a problem that we are going to face. It's not just in the aerospace sector, it's across the entire industrial base of the Western world. So new technologies are emerging that may make each engineer and each technician more productive. Things like artificial intelligence tools that make each engineer, each technician better, autonomy, robotic assembly test, all those kind of things are going to be really critical over the next 10 years to be able to sustain the kind of production rates that we've sustained over the last couple decades. That's comment number two. Comment number three, and I'll finish with this, is that the space industrial base today is not a true commercial market. I just hired a guy to be my contracts guy, and he had come from another sector of the industrial base. And over the first 2 months that he was working for us, he said, I have never signed so many non-disclosure agreements in my entire career. And the reason he has to sign these is that the way the space industry works today is not like you don't just get online and look at a catalog and say, I want to buy that part, and here's the tech data sheet on it, and here's the price. No, you have to send a non-disclosure agreement to that company. They review it, they review yours, that takes a week. And then maybe after you've signed that, they will slide across the table a tech data sheet. And then you can start looking, okay, this might work. And then you send them a ROM. And then maybe a couple weeks later, they slide one back to you that sort of says, here's what we think we can do this for in this amount of time and this amount of cost. It is the furthest thing from the way the commercial sector works and all the other, major parts of the industrial base. And it just points out that we're still very much operating in this kind of Swiss watch production line down at the component level. To build that, we've really got to grow the larger commercial marketplace for space, make this a bigger market so that companies are building things ahead of need, having catalog items, things on the shelf, and we're light years away from that today.
Thank you. David, over to you.
That was a very good explanation. If I go as deep as him, because I'm a federal employee and I can't speak from my own perspectives. I think the first point about germanium, all the precious metals, I think Within Space Force, we're doing a really good job of working with our CETAs and FRDCs to find the areas in which the critical technologies are either lacking or benefiting, so that we can stand up these organizations through Title III, DPA, other organizational constructs of funding from DOD, DLA, other entities, not just DOD, but from the Commerce Department or NIST or Department of Energy. So it's mostly of a combination of willing from the government standpoint to look at all these opportunities. Because if you look at it from just Space Force, yes, but every other organization is using the same materials, lithium-ion batteries, all these different materials, and trying to figure out ways to do better adaptability in space, longevity, taking legacy systems and actually reformatting them to make them more agile to last longer. So there's a lot of efforts going on. Also with the Futures Command, DEFCON, they're going down to Australia, New Zealand, working with other nations in mining and companies to see where we can explore opportunities to take those metals out of certain materials, germanium, for instance, in small portions. And if you take a small portion from several opportunities, you can have a larger tonnage of material you can use across the industrial base for space. So there's a lot of efforts going on. I think sometimes from a public standpoint, we don't see the needle moving fast enough. It can be political, but I think sometimes it's mostly of the combined efforts are so large, so decentralized. The public doesn't understand how much has been going on. So from our standpoint, we're trying to correlate all the willing together, working with our partners like NRO and OUSD, Secretary's Office, other offices within the Commerce Department to figure out how we can mitigate these concerns and bring these technologies and materials and minerals to the warfighter. So we talked about germanium, we talked about the wafers. When I first took this position about 16, 18 months ago, we had stuff sitting at DLA and stockpile. So our team decided due diligently to push to get those technologies, those materials out of stockpile to the vendor who was standing up a new organization in Ohio. And a lot of work went into that, like background work. It took months. It took us about 5 months to get this shipped over to the vendor. So it's nothing can happen overnight. You know, it's not like Amazon or FedEx or Costco. You go pick up something, it's shipped to your house, and within 3 to 5 days. It's a lot of work. So to do that, we're trying to figure out ways to do it faster and quicker. We're actually working with DLA to see if they can set up a space-centric office to handle all the materials, all the metals, all the raw materials, all the electronics, everything that's now is decentralized throughout different offices at DLA so that we can get reports. These reports be in a strategy session to see where we are lacking tonnages, areas of concern, get those to Space Force, get those all to NRO, to all our partners, NGA, so that we all understand where we stand. We can make decisions quantifiably together in a unified approach. That is the only way the space industrial base would move forward, because it's such a large area of opportunity, but it's also a large area of holes and opportunities that have not been found or fixed because of the presence that people don't understand how space is really set up. It's not like aerospace. It's not like land or sea. There are so many opportunities, but yet so many deficiencies because our supply chain industrial base is not up where it needs to be at. And we are tagged, each and every one of us in this room, in the government space, to make sure we do a better job to stand it up. On the second part of the workforce development, we have the same challenges in the space industry, in space for governments that the private sector does. So what we're trying to do is, part of one of the things I'm trying to do is maybe re-educate a lot of the different private sector jobs to say, hey, let's add some space influence to it. So back in January, a couple of us from Space Force took leave and went up to a university, Illinois State University. And what we did is we talked to the dean of the business school. We talked to the provost. We had a meeting with the president of the Illinois State University to talk about how can we add space-centric opportunities to teach kids in business school more about space, so they can take that effort and maybe come and be a PMO, program manager, one day at Space Force headquarters or at one of our Philcom offices. But also not just Space Force, but to work with other areas, including the private sector, because business is business. Space is just another part of business. If you're doing any kind of trade school, add a space-centric opportunity to that within those university or trade schools or community colleges to add to that space. And if you're doing something on the ground that can be adequately used in space, put in some workforce developments within the, local communities, cities, state efforts to build that out. And if your community doesn't have that, go to your senators, your legislative bodies and talk to them about, let's work closely with the DoD, with the small businesses in the area to repurpose and reprogram those people to help with the workforce development cycle. In the interim, we do have a lot of foreign nationals in universities who are seeking opportunities. And I agree with everybody said this week, they are very educated, but since we cannot really go through the barriers from our perspective to getting those students in the door of Space Force, because most of the stuff we do are highly classified programs, highly classified systems, and it's not that easy to break those barriers. And that's not up to us to do it at that level. That's a higher level approach. We can actually use these universities through NISN, National Security Innovation Network, and get them to do these tag ups to innovate these kids, get these programs work. We just did an FPGA program with Southern California, USC, and it was very successful. A 40-page document, how to do a lower cost FPGA. And everybody knows FPGAs and how much it costs to get these built in different stages for different satellite constellations and different sizes of satellites. So that is an opportunity to go to. We're also working with a local DIU within Southern California, as well as our NISN representatives as well, to figure out ways to use venture funds, local funds to help startups, build them an opportunity to build their companies. A lot of companies don't know how to even do business. They just know how to build a product. And that part of the business cycle is what's keep them going throughout the years when they're trying to do public-private partnerships with commercial and government. Because the government, yeah, it's very tough to get into, but the commercial side as well, they need to be formable and prepared and adapted for those markets as well. So there's a lot of opportunities there from a workforce development. And we can go on and on about that. I don't want to sit here and take that stage for that. But the third bullet about status of the industrial base, status of the industrial base, get what I'm about to say. So as we go forward with industrial base efforts, I think it's important to look at how we mitigate cooperative agreements. We talked about earlier today with the international partners. We are doing a lot of work here at Space Force Command, SSC, to work with Canada, because Canada is under the DFARS. And you can actually do work with DFARS in terms of Canadian companies right away. You have to go through the litigation processes, the paperwork trails. We had a meeting early this year with a Canadian official who's a DPA Title III official. She came down. We had a really good meeting with our International Affairs Office, how we can do better networking, better communicative tag ups in terms of industrial base. Because up until 2 years ago, Canada was doing a majority work for NASA. And they're looking at doing more work at DoD partnerships, as well as UK and Australia. And to the AUKUS comment earlier, I think from an AUKUS standpoint, Navy really kind of pushed that. DoD got in with Space Force being stood up to say, we need to do the same thing as Navy's doing and lead that effort. But a lot of AUKUS opportunities are being, there's so many opportunities to work with space mining down in Australia, with some of the stuff that's going on in New Zealand, especially with Germany and other companies jumping in. I know we refer to the Five Eyes as 5i Plus, because there's so many companies and so many organizations who want to come up and work with U.S. DoD efforts. So I'll just give you guys a little bit of transparency. We have a conference in the fall. General Gutlein put it together when he was at SSC. Now he's a VSSEO. And the conference is about international partnerships with 5i Plus nations. I will welcome you guys once we get it stood up. It's probably be on the SSC website, or reach out to someone at Space Force Command. We can give you it's going to be at Chantilly at the Aerospace Corporation campus. And it's about talking not just with the big primes, because I know the big primes are always brought up, but the small, medium-sized primes and mom and pop businesses who are really eager to get involved with not just working with DoD, but working cross-functionally across the whole space complex, right? So that's something I think that's important to make our small businesses stand up very strong, so we can have a very force-driven and very resiliency in supply chain industrial base. So I hope that was good enough. I probably forgot half the questions, but I was trying to get stuff in, so thank you.
No, it's a good overview. Thanks very much. And Chris, over to you, if you wouldn't mind giving us some opening comments about the space supply chain.
Yeah, so for those of you that don't know me, I am a financial analyst. I've been covering the industry for 25 years. So I don't build anything. I can't give you any real world experiences, but I talk to about everybody in the industry from, ground equipment and software and silicon to satellite manufacturers and launch. And what I would say is, yeah, we had this COVID period where everything sucked, and that was understandable. What I would say is, God, what is it now? Like 4 years out from COVID, things are still really funky, like more funky than I would think they should be at this point in time. And again, I'm saying that from the context that here's companies put up excuses, right? They're reporting earnings and they missed, and these contracts are moving to the right, or this delivery is slow. And just to maybe throw out a couple examples of things that seem weird. Um, a lot of commercial contracting stuff has slipped to the right. You've seen on the supply chain side, obviously, a lot of these big geo satellites that should have been built in 3 years took 7. And there are other, speaking of geos, I mean, the big new software defined satellites that SES and Airbus and Thales Alenia Space are building are like 3 years late. And this is a big issue as the geo guys are trying to compete, with the up and coming non-geo constellation. So these issues in the supply chain have very, very real world consequences for the companies. Now, one place I would say where the supply chain has gotten really good is on the launch side. And I think it only gets better as we go forward, not only with Starship, but Vulcan and ABL and Firefly. And crap, I started mentioning names. I'm not going to mention somebody and they're going to be mad. So I'm stopping. But getting access to space is not an issue, but building stuff still really is. Now, my perspective here is that for really, prior to 2015, there was no venture investing in this space. 2015 was sort of a tip over year where we had seen about I ran the numbers. It was $120 million a year globally in the decade prior to 2015. 120 million a year globally, venture investments into space. And since 2015, it's been billions of dollars a year and dozens of companies being funded. But here's the problem. Venture capital, which has become critical to a lot of the early stage development in this industry, which wasn't true prior to 2015, it's in the dumps, right? Since the SPAC peak of 2021, venture funding is down by over 50%. And, to make it even worse, venture investors, I mean, yes, they're investing in space, but this is all new to them, right? And the models that they like are 2 guys writing code in an apartment. They don't historically like CapEx heavy stuff. And we are a CapEx heavy industry, though interestingly enough, we're seeing lots of software startups. But regardless, the problem is this: of the 10,000 venture capital firms in the United States, well, maybe 15% will invest in hardware. And of the 15% that invest in hardware, how many invest in space hardware? And, add to that, we've had 2 going on 3 straight years of down funding. Investors have become much more tepid around investing in things that have very large CapEx tails. So here's the conundrum we're in. The industry clearly needs a lot more volume, just in terms of components, boring stuff like star trackers and reaction wheels and solar panels, and you name it. And that is not the type of stuff that the venture community wants to fund. It is really, really difficult. This is where I think having organizations like AFRL and DIU coming in and making investments that send an indication to commercial investors that, yeah, there is a demand for this product. And to be clear, I mean, we all love to think about the potential for the commercial industry, but the reality is, for a lot of these new markets that we're seeing and new constellations that are being launched, the primary customer is the government. So getting a government award, grant, loan, whatever it is for a government service that will be procured. I can't overemphasize the importance of it. That said, eventually, the government can't be the only customer, and these companies do have to develop, commercial business lines, and they need to raise that private capital because the government, again, can't fund everything into infinity. That said, I will touch on one comment that was made earlier, and I really never focus on this subject, and I just hope the government has our six here, is when you talk about the rare earth metals. I mean, that is and it's not space. I mean, it's aerospace defense, it's manufacturing. We in the space industry can't be responsible for securing a supply of germanium, but I hope somebody in the government is taking that as a huge priority, because it doesn't matter how many manufacturers of solar panels you have. If there is no germanium, we ain't making solar panels.
No, thanks very much, Chris. And actually, on that point, really quick, we have a paper on our AIA website about the top 12 critical minerals that are experiencing shortages across the aerospace and defense industry. Everything from germanium to titanium and copper, and some things that you might not even think about. So we put that out kind of recently. So just offer that as a resource to folks. Okay, great. So Peter, you mentioned that germanium was brought up at this conference a number of years ago. And now we finally have a $14 million contract that the Department of Defense cut just last month, which will probably take more time to build up the capability and trickle down to actually getting fully integrated into the supply chain. But was hoping to get the panel's thoughts on what you're seeing today as kind of some of the biggest shortages, whether that's critical minerals, or if you wanted to maybe highlight some components. I think we've touched on a couple of components already, but just, where are the top couple of issues that you're seeing today? Hopefully it won't take another 6 years or so to solve some of these problems, but what's at the top of your minds?
I think you touched on germanium, and we kind of helped push that effort along. There's two funding efforts. There's one through Title III for germanium, and there's another one through the State Department. So there's actually enough in the pipeline to help us push germanium forward. But there's other minerals along with that. I mean, the lithium issue is a big issue too, because we're using batteries on everything, cell phones to remote controls to car batteries. That's a lot of lithium. We got to look at areas to use different materials that have better resiliency for adapting batteries and also using space because of the complexity to mine these precious metals. And we don't do a lot at the US because that's also in other countries. And then we have to bring that home so we can do more manufacturing here. So they're building a giant plant in Kentucky for lithium. There's a car plant, but they're doing dual purpose to do space and batteries as well as car batteries. And there's an effort in Carlsbad. I mean, maybe the wrong city. I apologize, but it's in California where they're looking at doing space batteries, making the small 9-volt batteries and put them in packs, and then use them for space systems with small sats and medium-sized space applications. So right now we're publishing a CTL, critical technologies list with aerospace, and we're trying to adapt that into an electronic copy so you can just go in and go into the critical technologies list and pull up the list and see how there's an issue where it's not enough supply chain around that particular metal or substance or material, and then you can see where it's located and how the supply chain goes globally to domestically. So we can figure out ways to fix it. And then the NRO as well, and NASA use the same concept. But that's basically, I can give you a bunch of numbers and names, but I think overall those three are very, very critical right now. And then there's others too that keep popping up every day. So
from my vantage point, the companies that I'm working with, and Chris kind of mentioned this, that you look at some of the earnings reports that have been published in the last couple months, and there are a lot of companies that have missed their profit projections because their satellites were late being delivered from the vendors. Either they were building or had a company on contract to build. When you dig in the next level and try to understand, okay, what made them late? What I see, a couple of areas, flight computers, still an area where I don't think the industry is delivering on the pace that need to be delivered to maintain those kind of schedules. Recently, there was a lot of issues with propulsion systems. A number of companies were baselining the same prop system, electric propulsion system. That company ran into some financial trouble, and it's really slowed down a lot of deliveries. So what I see is really at that, not at the rare, I don't see the industry at the kind of rare earth level, metal level, but more at the component level, and it's just not robust today. You order a part and you really can't tell when it's going to be delivered in some cases.
Thanks. Chris, did you want to maybe comment on some specifics you're seeing? I know you already mentioned a couple.
Yeah, so just to follow on Peter's comment, have been just numerous issues we've seen where companies, because of supply chain issues, have decided to insource. So not that this was necessarily because of problems, but Hawkeye 360 was using Toronto Space Lab, or Toronto, I forget the exact name, that the university related manufacturing, and ended up bringing it in-house. You've got other vendors like Cesium Astro that seems to be building out a full satellite manufacturing capability. I think last month, AST Space Mobile, which does a lot of what they do internally anyways, they had a big delay. Stock got cratered because they had two supply chain providers that caused issues, and they resolved one of them and then ended up bringing the other part in-house. And I think it's been a trend we've seen here in the last couple of years, is more and more companies deciding to bring internally and vertically integrate key components themselves. And I don't know, like from a macro picture, how much sense that makes. Like in mature industries, certainly you tend to see a lot more specialization, and maybe the industry will trend that way over time. I mean, once your constellation's built and you're just maintaining and incrementing, do you really want to own the factory and everything else associated with it? So it may be that, somewhere down the line we see that swap out. But, for now, the supply chain challenges are causing a lot of companies to bring in-house things that they normally would have just outsourced.
No, thanks, Chris. Oh, David, you have something else you want to comment on?
So majority of my background is manufacturing. I spent about 20 years in aerospace and automotive. So yeah, taking things in-house kind of saves, you have a better quantifiable quality control perspective of that. Also, it saves money from internally by using internal resources to guide the process for manufacturing. But eventually, as you said, they probably bring it back out. But I think because of the way things are going right now, a lot of companies are saying, we'll cut the cost, bring it in-house, we can control it. It gives us a better opportunity to look at the life cycle from beginning to when it's shipped to the customer, so we can have a better understanding of how it's going out. Because relying on second and third vendors when the supply chain is very much all over the place, and you're getting stuff from different countries and not necessarily been tested or well versed if this metal is really sustainable for space and things like that, is causing a lot of the problems as well, and as far as logistics trying to ship things from many locations.
Well, thanks. So I'm going to have one more question for the panel before we kind of open it up to the audience and everything here. But I also am going to take a little bit of moderator's prerogative to mention a couple of other components that I've been hearing have had some issues, especially over the last year. So we mentioned star trackers, reaction wheels, wiring harnesses are hard to get a hold of these days. Space qualified radios and crypto and traveling wave tube amplifiers. So I'm just going to blast that out there.
What have you not named so far in the whole spacecraft bill of materials?
Go down the full
Yeah, I think
list
that's
of,
pretty much everything.
Satellite components, yeah. And then propulsion, mentioned electric propulsion, but there's also a lot of issues with just nozzles and tanks and kind of more on the chemical side there too. So yeah, pumps, valves. With all of that, my last question to the panel before we open it up is, what and we touched a little bit of this already, but what can the government do to actually help fix things here? Can it go fast enough? What's the U.S. government's role? What are the right mechanisms? We touched on everything from Defense Production Act funding to Defense Logistics Agency pieces. Hadn't heard about the State Department funding aspects, but just interested in the panel's thoughts of where are the right touch points? Where should the government be putting the foot on the gas to make things happen quicker? Or also, if there's any thoughts on where might it be appropriate for the government to just kind of step back and let industry kind of work itself out?
So I add one caveat to that. I got brought into the discussion recently about a few months ago. Space Force didn't have a place at the table for America Makes. America Makes is an OUSD effort that spun out. We need more help and more funding in additive manufacturing. So I attended an event back in Youngstown, Ohio, about 2 months ago as a Space Force representative to talk about how can we do better for additive manufacturing. And during that process, I learned that there's been a lot of efforts pushed over about a decade to help push this effort up. But I think a lot of people think that the government should go ahead and just do it, and we'll just jump in later. And as a test case, we may be able to do that. But I think fusing the opportunities for community approach for state, local governments, cities, municipalities to jump in the effort to build out the manufacturing, 3D manufacturing, additive manufacturing with different materials and components will be very, very will help resiliency in the supply chain. I know here in New Mexico, we have a lot of land. We can do that with. We can build some opportunities here to do the same thing. We talked about that in Oklahoma City. Ohio, Youngstown is an old steel city areas. We can repurpose some of these facilities to do so. I think it would take a little effort with DOD to look at centers of excellence across the manufacturing plateau to help do some of these things. But America Makes is one of the good transparencies. I know some people probably tried and say, well, it's expensive. Yeah, manufacturing is expensive. I mean, you look at some of the companies that are doing their own additive manufacturing, it's very expensive. I think to make it more conducive for small businesses and organizations who are here today, we need to look at a package of how we do this, maybe packaging several different machining efforts into maybe a cube or a module setting so that you can build out your prototypes, build out your MVPs, and then give that to the government to test and fly up on orbit. And then from that standpoint, build out your resiliency for your manufacturing process through these type of incubators within the municipalities, utilizing OECD, Space Force, and other entities' support. And then from that, you can get a lot of private sector investment, because I know it's very hard to manufacture stuff with the people who do not know what they're doing, besides the owners and the creators of some of these small businesses who really understand the concepts of doing so. So to tell someone else to build something that I have near to my heart, it's kind of hard to let go of that and to make that thing as important as it is to me, to them, and actually have a repeatability process on that. So I think from a supply chain industrial base for Space Force, we are here to help as much as we can on that. So anybody can reach out to me if you want to know about some of the programs they have. There's several programs going on with Army as well, where they can do one-off, and they have funding available to create different components that have not been created in years. The blueprints are lost. From that standpoint, we need to have a coalition of willing to have these programs available to small businesses as well, not just to agencies, so that we can get these programs running and get these vendors running and have a better manufacturing supply chain base.
Yeah, maybe a couple of comments. One, when I look at those components that you listed, reaction wheels, star trackers, propulsion systems, the real problem today at those vendors is that they don't have a warm production line. They don't build the parts until they get the order. And the industry is so lumpy today between big programs turning on and off that they're turning on and off their production lines and turning on and off employees. And the only way to solve that, I think, is to increase the demand. To increase the demand, you have to increase the market, make it a bigger market. I think there's two ways to make the market bigger. One is the international marketplace. And I really appreciated your question about what is the U.S. government's role in expanding the export opportunities for U.S. companies. I think that's really important, step one. Step two, I've been really pleased, excited to see the replicator initiative coming out of OSD. Today really focused primarily in the maritime and airborne sector, but OSD has recognized that to counter some of our near-peer adversaries with manufacturing at scale, we've really got to reshore a lot of the production systems for those kind of drone capabilities and other things. And so I think really expanding out that kind of replicator strategy into the space domain will also help grow the marketplace that will then ultimately filter down to those next level suppliers.
Thank you. So I've heard the space industrial base and supply chain being characterized as lumpy and now funky. Chris said earlier, so Chris, over to you. What's the government's role in fixing everything?
Yeah, so like I said, I'm a big fan of the government identifying core technologies and investing in it as a way to send a signal to the market. I do think there's a big donut there in the middle where, you know, I don't have a good solution. You know, are the private markets the right mechanism to fund the development and scaling up of these companies? But I'll give you a different model. I was just thinking about it. You know, flip over to Canada, right, with the Telesat constellation, and there's clearly a whole of government effort there through Telesat and as a prime contractor, MDA, you know, to invest in their space infrastructure. And what's kind of interesting about that is they're not doing, you know, the vertical integration play. In fact, they're building their manufacturing capability around that old Spar Aerospace facility up in Montreal. And really more of what they have is a cottage industry of mom and pop shops that are going to have to scale from 0 to 2 satellites a day is what they're aiming for production capability. And, you know, $2.14 billion of government and Canadian money, that's Canadian dollars, you know, that they just invested in the program, government of Quebec. But here's the alternative model. They've been spending, Telesat have been spending like 10, 20 million a quarter on Telesat related CapEx. They're going to spend between $1 and $1.4 billion in the next 3 quarters alone in order to ramp up that production. And this is what the model's telling you is they're doing massive upfront payments to a lot of their vendors and suppliers because, you know, they're dependent on shops that don't have access to capital. If you're SpaceX and you want to buy 100 of the latest, you know, high-speed tape machines, buy it, right? No big issue. Almost free access to capital. And that's a huge advantage that they have in production costs, right? Of automating stuff when others can't automate it. Well, you know, short of the Canadian government stepping in here and individually, you know, financing a bunch of small shops, what they've done effectively is through this Telesat MDA program is they found a way to forward fund, you know, the needed development, you know, and scaling at a lot of the downstream production within this program. So again, I'm not necessarily advocating for it. I'm just pointing out that, you know, that's kind of the extreme example of rather than investing at the, you know, the lead end of the supply chain, you're doing it from the opposite side.
Thanks, Chris. So I think we have time for 1 or 2 questions here. Would maybe open it up to the floor if anybody wanted to ask something or make a comment. And while he's coming up here, I'll just say that something that I think Chris, you know, just mentioned and Peter kind of brought the opportunities for proliferated satellite constellations to really help support the industrial base and the supply chain. I think there's a great opportunity there, and hopefully we'll kind of just continue to see that. Please.
I was a little disappointed to hear how kind of defense-centric this discussion was. You know, by the time that you guys notice that some little humble component is critical to the big piece up there, that little humble component has also been replaced throughout the entire civilian economy. You know, try buying a resistor from the United States, try buying a capacitor from the United States, try finding a PC. Actually, you can tell which PC board vendors are US because they're 10 times the price but 50 times the minimum order. You know, if you want to change, the Defense Department is 3.5% of US GDP. And space, of course, is a tiny fraction of that. If you want to change the behavior, you have to change the behavior of the larger American economy. You know, running around and pouring water on the fires that you find is not, it's a valuable effort, but it's not going to change anything. And there was and I have a suggestion, there was a brief period when the tariffs on China came in 2019, when for the first time you could tell which parts were coming from China, because they all had a little thing that said this part may be delayed because we haven't figured out how we're going to handle the tariffs yet. It only lasted about 8 weeks, but you could tell all of a sudden which parts were coming from China. And guess what? There were alternatives. Yeah, they were 10 or 20% more expensive. But I bet I wasn't the only company who said, well, gee, now that I know that there's other places to get those components from, I'm going to change my buying behavior. You as the DoD, we can't just back out of the WTO, whether that might be a good idea or not. But there's nothing in the WTO that prevents countries from requiring point of origin labeling. In fact, almost all countries other than the US do that. And the DoD could pressure our trade regulating organizations to do that, simply to require point of origin labeling so you can tell where the component comes from. And since virtually every part of everything shows up in a DoD system somewhere, you could apply that pressure to change the buying behavior of a significant fraction of the American economy, and that would be a highly leveraged activity for you.
So if I could maybe just summarize that question quickly, or that comment of thoughts to the panel on what role could things like tariffs do to maybe try to shore up and increase domestic manufacturing capabilities? Any thoughts there?
So I add something to that. I just had a conference about 5 weeks ago. It was in Los Angeles. We talked about discrepancies similar to what you're talking about. We are working with startup companies to figure out ways to do that. I know you want a bigger answer to that, but I can't give you that answer. But what we're trying to do at Space Force is actually work with small businesses. And when I talked to the couple companies down in San Diego, we're going to do a visit with them and look how their systems can disseminate discrepancies and the parts issues. Take that technology and see if we can get that through SpaceWorks. And once you get it through SpaceWorks and build it out and put this under the program offices, all the program offices and POs at Space Force is using this type of software to disseminate between that, it would help that effort. And then once it gets pushed up, hopefully someone at the Pentagon can say, hey, that's something we need to look at from a policy standpoint and hire. So it's efforts you can do. I can't get into the political side of it because it's not where my forte or where I work at, but the small business areas in which we can mitigate these concerns, we're trying to do that. And DARPA also is working at that from their microelectronics side. So while I was at that meeting and I spoke, I had a DARPA advisor to the director speaking about the same thing for microelectronics, how we need to get this fixed and fix in a hurry.
So apologies, we have run out of time here today, but I think this is a great discussion. Probably could have had another couple of hours talking about these topics. So please join me in thanking our panelists for this great discussion on space supply chain. Casey, back to you.